Let us look at the world from a simpler and more fundamental perspective. Everything around us operates on signals. Communication systems use coded signals to transmit information, whether in simple forms like Morse code or in complex binary systems used by computers. But beneath all of this is something more fundamental, and that is energy. Without energy, there are no signals. Without energy, there are no systems. Every device we use depends on energy. In many cases, that energy comes from batteries, and those batteries are controlled corrosion systems. This gives us a powerful way of looking at the world. Corrosion is not just a process of decay, it is energy in motion. It is a process where materials interact with their environment and generate measurable electrical effects. These effects can be studied, measured and understood. This is why corrosion science is so important. It gives us a direct way to study how energy behaves in real systems. However, many traditional methods rely on indirect measurements. They measure voltage or electrical balance, but they do not directly measure the activity that matters most, which is the movement of charge. To truly understand what is happening, we need to measure current, because current represents real energy flow. This is exactly what the Alexander cell does. The Alexander cell measures real corrosion current. It shows whether energy is being released, whether a reaction is active, and whether that reaction has been controlled. It makes an invisible process visible. This allows us to move from assumption to evidence. We can see when corrosion is happening. We can see when it stops, and we can see how systems influence it. In doing so, we gain a deeper understanding, not just of corrosion, but of energy itself. So when we talk about science, we're not just talking about theory, we are talking about measurement, about observation, and about understanding reality. Corrosion science gives us that pathway, and the Alexander cell allows us to measure energy at its source, directly and clearly. And that is what makes it such a powerful tool for understanding the systems that shape our world.